Alright, so welcome back. So what we want to do this time is we want to print a game cleaner. So if we just kind of look at what this should do on the finished app. So the idea is if I click in one of these squares, we should get a printout over here of what the game object looks like. So you can see that the game object looks like it knows the state, so it's saying X's turn, and then it's displaying what the board looks like, you know, just kind of in a little ASCII sense. So if we put an O on there and then another X, and then an O and then an X, it's always displaying like what's the state of the game, and then what does the board look like. And then of course if we make O win, we can see that the state says O wins, and then here's the state of the board. And you can think about how this array kind of works under the hood. So that's our goal. So we want to be able to print this thing out better. So let's go work back in the playground. And the way that you actually make something print as a class is it needs to implement the protocol printable. So printable is a protocol that you can use. If you wanted to learn more about protocol, you can option click on it and it'll tell you a little bit about it. You can also command click on it and it'll like take you into the code, and you can see what this protocol actually expects. So what this protocol expects is it expects for you to have a variable called description, and this variable called description is actually a computed property with a get on it. So what we're going to do is we're going to actually do that. So we've said we implement printable, but you can see that it's throwing an error because we claim to implement printable, but we don't actually have that description variable. So what we're going to do is we're going to make ourselves a description variable. Typically, the types of variables that we've taught you about are what are called stored properties. So it's actually a variable that's stored with the class. But there's also something that's a little different. It's called a computed property. So a computed property has a way that you can get it, but it's not actually stored. It's just, it's computed real time and you just get it whenever you need it. And so what you can do is you can actually make a computed property for description that would, return something. So let's say temporarily it just returned test. Oops, and it's yelling at me because I didn't say what type of variable it was. This is a string. Sorry about that. Thank you, compiler. And so this is how you can do a computer property. It turns out that there's also a shorthand because this kind of looks confusing because there's actually like a get, and then there's also a set, which is kind of weird. I don't really want to go into it. But if your only thing you're doing with a computer property is a getter, which is very common, you can actually just use a single double curly brace, so before and after, and it'll use the getter is what it's going to do. So this right here, if we actually used it in an app, would work great, right? And so whenever we printed out the class, it would actually work out very well. And so in this case, it would say test, right? However, there's a little bug. I don't know if bug's the right word, but in playgrounds, it doesn't work to say test. Maybe they'll get that fixed. I'm not really sure if they're planning on it. So in Swift Playground, if you actually want to see it print the word test, you need to call description on it, and so it'll actually give you the description property. So to be honest, that's just kind of a little hacky workaround that you have to do in playgrounds. And so to be honest, what I'd really like to do is I'd like to be able to go and uncomment all of these things. You can see that it's yelling at me about the function press square. So fine, I'll just get rid of that error. And I'll make a function called press square. It looks like it's receiving an index for what int just got clicked. And we'll just say to do, implement later. I'll even put a little smiley face just for myself later so I'm a happy guy. And so you can see that it's actually printing, test, 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 test. And, we could uncomment the second block. This is the game that O is going to win. And so it's working, except for the fact that it's printing test every time. That's, of course, not the goal. So what we'd like to do is we'd actually like to print something about this game. So one of the things that we want to print is we want to go ahead and print the game state. And we don't just want to print the enum version. We want to print the raw value of it, right? So with just printing raw value, we can see that there's a change, and it actually prints X turn. If you remember what we wanted to print, though, we wanted to do more than that. We actually wanted to print out the entire board. So what I'm going to do is I'm just going to say board, and then I'm going to make a function to help me print out the board. I'm going to call this function getGameString, and so this will be like the entire game, right? It's, of course, complaining that getGameString doesn't exist, so let's go make a getGameString. So what getGameString is going to do is it's going to return a string of X's and O's. And so what we want to do inside this string is we want to actually print out an X or an O, like depending on what the mark is. I'm going to be sneaky though. I'm actually going to use this function again later. So if I wanted to like see like, what is the value in like 0 and 3 and 6? If I wanted to make a string out of 0, 3, and 6, I wanted to be able to do that by passing indexes into it. So what I want to do is I want to actually create an optional parameter to where if you want, you can pass in certain indexes and I'll give you a string over just those indexes. So what I'm going to do here is I'm going to say indices is an array of ints, and I'm going to give it an initial starting value. I'm sure there's some clever way to do this, but I'm just going to give it an initial starting value to include all of the indices, right? So if somebody passes in nothing, what I want it to do is print out everything. But if they want to, they can actually pass in an individual index. So in order to actually implement this thing, what I'm going to do is I'm going to create a string. I'm going to later return that string. And then in the middle, I'm going to loop over all those indices, and I'm going to add things to it. So for index in indices, I want GameString to be plus equals of the game board at the location index dot raw value. So what that's going to do is that's going to add an X or an O as appropriate depending on what the game board is doing. And we can actually go down and look at those. And so you can see that this first board relies on press square, and so it never actually changes the board, never actually changes the turn, but you can see it worked, right? So it prints 9 hyphens, which is good. The second one is a little bit more interesting. So it actually prints out X's and O's, and that's because we kind of manually loaded up a board as part of this test. And then the third one also shows a board because it manually loaded up these values for the test. So that's it for printing. So we've got a description. We implemented our first ever protocol, so we learned a little bit about protocols. We used a computed variable instead of a stored variable. First time we've done that. All these little things that we have to pick up as we go. We also learned about the Playgrounds bug to where if you say print, it doesn't actually print right. And so in Playgrounds, at least right now, you have to actually call a description. All right, so that's it for the printing of this thing. Come back next time and we'll actually implement the TicTacToe game. See you then.